Good morning, class. Today is Tuesday, February 16th, and the assignment is in IXL section I, numbers 1 through 3. So we're going to look at section 1 first, I1, and the title of this section is Find the Constant Proportionality from a Table. So we are here in IXL. To get to a page like this, when you first start a unit, if you remember, you get to your first question in the unit, and you can click on Learn with Example. So anytime you're starting something and you're not sure how to do it, this is a great way to go back and review. You're going to get a question like this. The housekeeping staff at the Weary Traveler Hotel rotates job assignments every day. Today, Jamie is in charge of folding the freshly cleaned bed sheets. There is a proportional relationship between the amount of time in minutes Jamie spends folding, which we'll say is X, and the number of bed sheets he folds, which will be Y. If you remember, the proportional relationship means that there is an equal proportion as we get to more minutes, the same amount of more bed sheets will be folded. So here's a table of Jamie's minutes spent folding and the amount of bed sheets he folds. So what we're going to try and find from this is the constant proportionality, which means what's the rate at which he's folding the bed sheets. We're going to find out how many bed sheets per minute Jamie folds. Here's the key idea. We've talked about this a lot already. Two variables have a proportional relationship if the ratio of one variable to the other is constant. Okay, so we're assuming that X and Y have a proportional relationship. Actually, we're being told that. The constant proportionality is the ratio of Y to X. To find the constant proportionality, calculate the ratio of Y to X. So if you look here, we are going to take Y and divide it by X. So we're writing it as a proportion this way with Y over X because we're calculating the ratio of Y to X. And we find that it's 3. You can go through and do it to each section. 3 divided by 1 is 3, 6 divided by 2 is 3, 12 divided by 4 is 3, and 18 divided by 6 is 3. So the ratio for each pair of X and Y values is 3. The variables have a proportional relationship. So the constant of proportionality is 3 bed sheets per minute. So remember, we can infer then that if this number doesn't equal the same on each section, then the relationship is not actually proportional. So in the ones we're practicing today, the variables should have a proportional relationship, meaning the ratio when you divide it is the same each time. Okay, we're going to go back to practice, and I'm going to talk about this one. While relaxing on her front porch, Dana notices a garden snail crawling on the sidewalk. Dana is amazed at how slowly the snail moves, so she starts timing it. Again, when we're reading story problems, there's a lot of information that we don't actually need that sets the story up. So don't get tripped up on some of this early information. There's a proportional relationship between the amount of time in minutes that Dana spends timing the snail, which is X. Here's our X column. And the distance in feet that the snail moves, Y. Okay. If we remember, we're going to try and find the constant proportionality. So we're going to divide the Y by the X. So we could maybe do this in our head. 6 divided by 3 is 2. 10 divided by 5, also 2. 18 divided by 9, 2. And 20 divided by 10 is 2. So there is a constant proportionality, and the answer is 2 feet per minute. We're going to do something very similar here. I'm going to do one more with you guys. If you already know how to do it, you can go ahead and go do it. Otherwise, stick around and I'll do it one more time. Chalk Arcade has Robert's 2 favorite things, a chocolate shop and an arcade. Not only that, but Chalk Arcade's loyalty program rewards Robert with free game tokens every time he buys chocolates. Sounds like a good deal to me. There is a proportional relationship between the number of chocolates Robert buys, which will be X, chocolates, and the number of free game tokens he gets, Y. What is the constant in proportionality? Write your number as a whole number or a decimal. So we're going to do the same thing. We're going to divide the y value, the tokens, by the x value, the chocolates. 4 divided by 1 is 4. Okay, let's check 8. 8 divided by 2, 4. 12 divided by 3, also 4. 16 divided by 4 is also 4. So we've confirmed, yes, there's a constant proportionality, and that number is 4 tokens per chocolate. I want you to carry on doing this with this section, and when you're done, come back to the video. So pause the video now, finish I1, and then come back and we will work through the next section, I2. Okay, hopefully you have finished section I1, and we're starting in section I2. So if you haven't done I1, make sure you go back and do it now. In section I2, we are writing equations for proportional relationships from tables. So we're going to use the same skill we did, but we're going to find out how to write an equation to solve for y if all we have is the x variable. So this is getting into some of our pre-algebra skills. And hopefully, since you've done the first section, I1, you have it in your mind kind of how we get to these numbers and how that proportional relationship will make it easy for us to find out if we only know how many minutes in this, I haven't even read this example, but if we already know how many minutes we have, we could do an equation to find y. We wouldn't actually have to chart it. So for example, this holiday weekend, Max is going to Chicago to shop and see a baseball game. To avoid traffic, Mac decides to take the train. There is a proportional relationship between the time in minutes Max spends riding the train, x, so x is the time he spends riding the train, and the distance he travels in miles, which is y, so this column. Okay, I'm gonna switch over to my dot cam, and we're gonna talk through how we're gonna make an equation where we could only have the number for y and be able to solve, or we would only have the letter for x, or the number for x, and be able to solve for y. Sorry, I'm stumbling over my words. We're going to make an equation where if we only have the minutes, we could know how many miles we are without actually measuring it out or using a table. Okay, so I've written our table here, and what we're going to do is find the constant proportionality. So we're going to calculate the ratio of y to x in order to do that. If you remember, we did that in section 1. So to find the constant proportionality, we're going to calculate the ratio of y to x. So in this case, we're going to look here and do 5 over 5, which equals 1. In this case, we're going to do 6 over 6, which equals 1. The same for the bottom two. So we know that the constant proportionality is 1 for this table. Now from there, we need to find the constant proportionality, so 1 mile per minute. And in this particular equation, all we know is that the number y is actually the same as number x. We could actually probably see that. You obviously can see that from the table itself. But what you're going to do is, you know that 1 is the constant proportionality. And so we know that 1 times x is going to be y. So we don't ever need to write 1x because any variable you can assume has a 1 in front of it. So we don't need that. So in this particular equation, y just equals x. We know that if we have driven, say if we went 25 miles or 25 minutes on the train, we know that we would have gone 25 miles, going a mile a minute. Okay, we're going to do another one that has a little bit of a different flair. Let me grab one from IXL and I will share here on the board. Here's our next question. Dana is finding the perimeter of different sized squares. There is a proportional relationship between the side length of the square in inches, which is x, we go, X. And the perimeter of the square in inches, which is Y. If you remember, perimeter is the distance around, and the side length is just one of the sides. So in this question, they're asking us to write an equation for the relationship between X and Y and simplify any fractions. We're going to go over to the dot cam and write out how we would solve it by hand. Here we go. I've already written the table for us, and we're going to go ahead and go through and solve this equation. So we know that, excuse me, we know that we first have to write the ratio of Y to X. So the inches in perimeter per inch the inches in the perimeter per inch in the side length. So we have the inches of the perimeter per inches of side length. So we know that for a 4-inch perimeter square, a side length is going to be 1. You might already know in your head how you're going to solve this, but I'm going to still go through it. So if you ever have one that's more tricky that you can't do in your head, you know how to find the answer. So in order to find the ratio, we're going to divide Y by X. So in this case, we have 4 over 1. We're solving that ratio, which is 4. 8 over 2, which is 4. 12 over 3, which is 4. And 20 over 5, which is 4. Okay, so we know that the constant of proportionality is 4, and that they have a very clear proportional relationship. So we know that as the perimeter of the squares get bigger, so do the lengths of the sides. So the constant proportionality is 4 inches in perimeter per inch in side length. So we know that for every 4 inches of perimeter, or sorry, I should say for every 1 inch in length, there's a 4-inch perimeter. So we can multiply 1 by 4 to get the perimeter. We're going to do the same thing with the X column for the second one. We're going to multiply 2 by 4. So we know that any length we have in X can be multiplied by 4 to find out what's going to be in the Y column. So in this instance, it's going to be Y equals 4. You can go through with any of the equations in this section and do this same strategy and be able to get your Y value. Go ahead and do that, and I'm going to come back and do section 3 for your last assignment of the day. So pause the video now, and when you come back, we'll work on section 3. All right, we are starting section I3, identify proportional relationships by graphing. This is one of our first times graphing this year, though you might remember how it works. We used it a little bit in science as well. You're going to have a question that looks like this. Sean is determining the number of quarters equal to different dollar amounts. $1 is equal to 4 quarters. $2 is equal to 8 quarters. It's great we're doing something here that has a proportional relationship that you already have a firm understanding of in your head. So in this relationship, we're going to graph the relationship that's a relationship you already know. In this relationship, X, which is the bottom line here, X represents the amount of money in dollars, and Y, this vertical line here, represents the number of quarters in that dollar. It says graph 2 points for this relationship and the line passing through them. So what you would do in this situation is you can look here and say, okay, well, if it's $1, it's 4 quarters, and we would have a point here. I'm going to add this to my document camera, and I'll show you what it would look like if you went through and graphed it. Here we are with my just roughly drawn graph. It's the same thing that's on the computer. And what we're going to do is find 2 point values for this relationship. So if Sean is determining the number of quarters equal to different dollar amounts, we know that $1 Again, the dollars are here on your x-axis. I'm going to put this here to remind us. And then the number of quarters are here on our vertical y-axis. That kind of looks like an x, sorry, y. We know from our question that Sean is determining the number of quarters equal to different dollar amounts. So $1 is equal to 4 quarters. So for $1, it is 1, 2, 3, 4 quarters. Okay, and we would write those coordinates like this. 1, we always have our x first, and then 4, which is our y value. The next thing that we're going to do is plot another point, because that was the next part of the assignment. So if we know that he has $2, we know he's going to have 8 quarters. So on graph paper, you could count it by the line. So I'm just kind of estimating. There's 4, 2, and there we go. So we're finding the point at which the ongoing line for 2 and the ongoing line for 8 intersect right here. And we're going to write those coordinates as 2, 8 in parentheses. You could continue doing this as you go. You could go 3 and 12, but you can see already that this has a directly proportional relationship. So we've plotted the points on the graph as we've been instructed to. The next part of the instructions was to draw a line through them. And so to determine whether x and y have a proportional relationship, we have to see if the line goes through these points and passes through the origin 0. So we're going to go 0's here, right at the beginning. I only have a giant meter stick, so I'm trying to draw a straight line here. And if I had graph paper, it would be more perfect, but it's pretty close. Let's see if I can get it. There we go. Now, if I had graph paper, those would be directly on that line. So you have to kind of imagine with me. Let's go back to IXL so you can see what it looks like on a true graph where it's correct. We pull that up. Here you go. So you can see if you have equally spaced graph lines and you've plotted those 2 points the way I just showed you, when you draw the line from 0 and on up, it intersects all of those points. So we know that the line increases at a steady rate. So x and y have a proportional relationship. So when we're asked that question in IXL, all we need to say is, according to the graph, do x and y have a proportional relationship? We can say yes. So let's go back and look at IXL really quick. So it's going to ask us to solve this problem. Akira loves to play the piano, but doesn't like practicing the exercises her piano teacher assigns. Akira knows the exercises will help her play better, though, so she tries to motivate herself using her favorite treat, chocolate chip cookies. When Akira practices for 3 hours, she gives herself 3 cookies. When she practices for 5 hours, she gives herself 5 cookies. In this relationship, x represents the amount of time in hours that Akira practices the piano, and y represents how many cookies she gives herself. So we're going to graph those 2 points. Let's go back to what she says. When Akira practices for 3 hours, she gives herself 3 cookies. So we're going to go on our x-axis and go to 3 hours and go up according to our y-axis to 3 cookies. That's our first point. See, it's already starting to let us figure out the lines. This is much easier than drawing by hand. Then we're going to plot the next point. When she practices 5 hours, she gives herself 5 cookies. We're going to go to 5 hours and go on up to 5 cookies. We can see that this line is a straight line through 0 on up, and the relationship is directly proportional. So we have to plot those 2 points, and then we can go down and say if they have a proportional relationship, and the answer is yes. So you should be able to go read through the story problems, and then you do the graphing, and then decide whether or not it's proportional. Remember, if it's not proportional, it will not intersect 0 and go consistently upward. If you have any questions, feel free to reach out in Zoom today. Otherwise, I hope you guys have a great day.